In this video, I'll be covering SQLIO more in depth. I'll be going over and demonstrating various test scenarios that are useful for using SQLIO to test data warehouse workloads or to simulate data warehouse workloads on your server. Now, just as a review, I highly recommend that you watch the preceding videos. They'll give you a good foundation for understanding SQLIO and the importance of measuring your system's throughput. As described in those videos, throughput is the measurement of a data warehouse server's performance in megabytes per second and forms the foundation or the capabilities of the database engine. The database engine cannot perform faster than the throughput capabilities of the data warehouse. And so to be able to test this, you can download SQLIO. It's a free little executable from Microsoft, and as despite that its name implies, it has nothing to do with SQL Server, the database engine itself. It is simply a tool that writes a test file or reads from it in a variety of ways, which I will cover in order to test your hardware system's performance. So now I will show you what it looks like after you've downloaded the SQLIO. So SQLIO is a small executable. Now you can leave the exe, SQLIO exe in the location, the default directory that it installs into. However, I like, since it's a standalone exe, I like just to copy it into the location that I want to test. Now I'm going to emphasize this again, but I like to keep everything that I'm going to test in the same directory with local to the disk that I am going to test. For me, that helps keep everything straight, particularly in scenarios where I have multiple disk groups that I will be testing, multiple LUNs that are exposed to operating system. It can get a little confusing keeping those things straight if you have files in different locations, and I'll explain to you why that is. So I also want to, and I'll mention this a little bit further on, I want to give credit to David Lee. He's a SQL Server MVP that has put together some things around SQLIO that I've kind of expanded upon and adapted for data warehouse specific workloads. So this setup is his, and to a certain degree that I've kind of taken and enhanced for data warehouse type workloads. So to begin with SQLIO, here's the executable. Now the SQLIO TestBat is what starts this batch file. And if I look at that batch file, all it's doing is calling the child test batch file, and it's going to dump the results to the results text. So I'm going to call this child test batch file and dump the results to a results text file, which doesn't have anything in it right now. Well, I ran this previously. I'll just delete that out of there. Now it won't have anything in there. So in terms of the test file, in terms of the child test file is the file that contains all the different test iterations or scenarios that you will be testing. So it's a simple call to the SQLIO executable, passing in several parameter values. So this first one, this K, indicates reads or writes. A capital W for reads, a capital R for just capital W for writes, a capital R for reads. T, switch, is for the number of threads. S is for the seconds or the duration of the test. O is for the number of operations. So these are the number of concurrent reads or writes operations that are requested, and this is equivalent to the SQL Server's queue depth simulation. F is for the format, or either spelling out specifically whether or not these reads or writes are going to be random or sequential. B is for block size, which is very important for data warehouse scenarios. These I do not touch, and then this F calls additional parameter values, which I'll discuss right now. So my param text file has the location of the test file that I'm going to create. It also has, you can affinitize to certain threads to certain CPUs if you want to do that. I do not do that, and it's not really appropriate for data warehouse type workloads. If you had especially affinitized CPUs in very highly tuned OLTP systems, that might come into play there. This last one is the size of the test file. So two very important things here, and this is why they're separated: the location of the test file and the size of the test file. So in terms of the location, wherever this file is placed, that is where the reads and writes are going to be executed from. So the set of disks that this is placed on determines the disk that you are testing. Now I have a laptop with only one drive, the C drive, but in most situations you're going to have a data warehouse that has multiple drives or LUN groups exposed, disk drives exposed to it, and so you need to be very careful, you know, which drives you are testing, and that you're not only just testing the C drive, which is the operating system drive. So that's very important. The next very important thing is the size of your test file. Now this applies to SAN type environments, because some SANs have additional caching or tiers available to them, and so what you want to make sure is that your test file size, and this is in kilobytes, I believe, yes, it's in kilobytes. You want to make sure that your test file size exceeds that of your SAN cache. If you don't do that, then you are testing merely the performance of the SAN's cache and not necessarily the performance of the underlying disks. The reason for this is because most data warehouses workloads will not fit into the SAN's cache. Let's say the SAN has a cache of 8 gigabytes, but your data warehouse queries are typically 10 gigabytes or larger. That means that they will not fit in the cache, and so you don't get very much benefit using the SAN's cache. That's separate from the fact that you're using a SAN for data house workloads, which isn't appropriate to begin with. But if you want to insist on using it, then you need to make sure you know what you're testing. And so if you want to test the SAN's cache, make it smaller than that. If you want to test that underlying disk, which is more appropriate, test something larger. So now right now I'm on my C drive, and I'm going to start the test. I'm going to kick it off, and I don't have the test file created yet. I wanted to show that to you. So when I start this, what it will first do, since the test file does not exist, it will first create the test file and then start running these tests in serial. Okay. Now even though they're running in serialized fashion, these operations are actually forms of parallelization. So for this particular set of disks, remember one disk group at a time for this particular type of test. So if I start that, I get the command prompt comes up and it starts executing, and my test file starts being created and populated. Since I specified 1 gigabyte in my test file, that is created at that time. I go back to my command prompt, and my command prompt is executing, and I open up my results text, and I have the beginning of the output for the first test. The beginning for the output of any of these tests is going to start with the writing the parameter values at top, followed by the specific output of those tests at the bottom, and then the next set of parameters for the next test. So one thing to be aware of here too, in terms of your seconds for your test, you want to try to pick not only the appropriate size as explained before, but also a test length that properly tests the capabilities of the server. So So hopefully something on the order of, and this depends on your window as well, how long you have to perform these tests. Ideally, you would want to perform these tests on a test environment, which is a copy in terms of hardware of the production environment. That way you know that these test results are indicative of production. If you don't have that, then to get an accurate measure, the only way you can do that is to actually run these tests on production, which will have a performance impact on production. Maybe you can fit it in during a maintenance window or something like that, but ideally you have a test environment which is, in terms of hardware, a mirror of your production environment. It doesn't have to have the same data, your test environment, because we're not testing SQL Server. All we're doing is testing the underlying hardware capabilities. So now, if I look at my test results, now the tests are continuing as indicated by my command prompt still up here. So they're continuing to run, and I'll just let them run it for now. But so this is what the results of one test looks like. So here's the call out to SQLIO. Here I am, in terms of reads or writes, I'm doing writes. Threads, I'm going to have to start with 2. In seconds, 100. Now you want to increase this in a real scenario, but for my demonstration purposes, it's just 100. Operations, queue depth. Random, I'm testing random. Now you won't want to do this particularly for data warehouse scenarios, but if people are interested in what the random performance is, then you can use that. The most typical scenario is sequential. My block size, I'll get back to that. Right now it's 64K. And then my parameters controlling where the test file is and how big it is, right there. So you can read this here. This is just tells you what I just told you essentially about the values of the parameters and how big the test file is and where it is. And so initially the test file was expanded from an initial size of nothing because it didn't exist to its current size for testing purposes. So the important data points begin here. So your throughput metrics, as they're called. So you have 2 here, major ones. You have IOs, so you have in and out operations per second, and then you have megabytes per second. This is for data warehouse scenarios what you're focused in on, your megabytes per second. So that's the metric there. Your latency, in terms of data warehouse, latency isn't that big of an issue because your response time, whether it's a few milliseconds or not, is not going to matter when our queries take 10 to 15 to 30 seconds to come back, a single query. A difference of a few milliseconds isn't going to affect that one way or another. So now you're gonna have lots of these tests. One thing that I recommend, and I mentioned this previously, is that a SQL Server MVP by the name of David Lee put together a nice little tool that once your result sets your results are completed and your tests are completed, you can upload that text file into his website here, his SQLIO website, and you can actually there it is. You can actually, he will produce a tabular view of this data. So he'll pick out all those parameters and the results into a tabular format, so you're not having to essentially copy and paste or from the results text here. Otherwise you'd have to copy and paste all the stuff one by one manually. He has a little program that'll do that for you. So I use that, and it works great for my purposes. So there's that. Now if I go back to my test results, I see that the next test is now complete and is continuing on to a 3rd and 4th test. So I'm going to go a little bit more in detail. I'll stop that for now. We'll go a little bit more detail. I've also put together an Excel file for those parameter values. Now this Excel file gives you a potential of many hundreds of tests that you can run on your server. And so I'm going to go through these in a little bit more detail. So reads and writes. Obviously for data warehouse scenarios you want to test both reads and writes. So your reads are your query performance, your writes are mainly what we're talking about here is your ETL performance. How quickly can you write data in onto the server? So that will affect ETL performance there. Your threads, I go ahead and test the full spectrum of threads. Sometimes you get unexpected behavior or differing behavior depending on the threads you choose, and so it's good to collect a wide range of information that way. I already talked about seconds. You need to pick a amount of seconds that will fit into the time frame that you're allowed if you're having to do this on production. If you can find a test environment that's a hardware duplicate or a copy of production, then you don't have to worry too much about that and just pick something that's appropriate given the number of tests you're going to run. And many times you run several hundred tests at a time. Your operations, again, your queue depths. So those are pretty straightforward as well. I usually run the whole series there, all possible values there, to get an understanding of how it performs with different queue depths. So now your format or the type of reads and writes that you're going to be doing, random or sequential. You want, for data warehouse purposes, sequential reads and writes are what is important. Random reads are not important. Still, you might choose to do the random tests for purposes outside of data warehousing, particularly if you're happen to be on a SAN and you're wanting to test its performance that way. Block sizes. Now this is really where, for SQLIO purposes, this is where data warehouse workloads get really specific here. So most block sizes that SQL Server uses under an OLTP scenario are 8 kilobytes. So 8 kilobyte pages, 8 kilobytes on a page, which is the page size. However, with SQL Server's read-ahead functionality, which I explained in previous videos, SQL Server can increase its block size, or in fact its efficiency per I/O request, and actually return, instead of one 8 kilobyte page, it can return multiple pages per I/O request, even without the operating system requesting multiple pages at the same time. It just returns it. So that's why you need to pay particular close attention to increasing the block sizes. So what I have here is starting off at 64K all the way up to 1 meg block sizes, and you could even go higher than that depending on the performance of your system. So and I'll show you some charts later, but what happens is when you start running these tests, usually I run these tests on just 64 block size and all the possible operations, threads, combination of those guys just at 64K, and then I see where the maximum is there, the maximum performance is there, and then I use those values from the threads and operations where performance is maximized to then increase the block size to a point where then performance starts leveling off. There's no more increases in performance as I increase the block size. Once I know that there's kind of a level off effect in terms of performance, it doesn't perform better, then I know I've reached the maximum performance of the server, and that is its true optimal performing capability. So that's the approach I use. It seems to work very well for data warehouse type scenarios. I don't touch the other parameters there. And there is also a rich text file that comes with SQLIO that goes into a little bit more detail with these parameters and things like that that you should read for your own knowledge and information. So now with that said, I want to revisit. Oh, okay. So and this will come into play a little bit later as when I explain parallelism. But so here's this test file that was created on my C drive. Now I should, in most data warehouse scenarios, and I'll explain parallelism in a video ahead, but you should have multiple disk groups that work in parallel, meaning they have a database file on each of the disk groups. And so what you want to do is test one of those disk groups, find the optimum performing level of that, where it performs the best, and then test all the disk groups that have database files on them in parallel. So in other words, you would have to copy and paste these SQLIO files to each individual LUN disk group, and make sure that you change the parameter to reflect, hey, okay, now this is going to test D now and E and F, or however you have it set up. But in my, of course, my laptop only has one disk, and so one drive in that sense. Okay, so now with that information, you should be able to understand my charts that I presented way back in the first video a little bit better. So there's SQLIO. Before I do that, I really want to hit home the fact that you are creating a test file on the Windows server. This has nothing to do with SQL Server. So when I say this tests performance, it does to a certain point. Now, if you have a bottleneck somewhere between your disk and your storage and your HBAs, SQLIO will not show that. In other words, SQLIO only knows the performance of the test file being written at the Windows layer. If there's, for example, an HBA, let's say you're delivering 2 gigabytes out of your storage, 2 gigabytes is going through your controllers, and 2 gigabytes is going through your file channel switch, but your HBAs are not multipathed, and they're only delivering 1 gigabyte instead of 2, the results of your SQLIO test will show only 1 gigabyte of throughput instead of 2, and there'll be no indication that actually your system is capable of more. So SQLIO in some instances is only the starting point. If you suspect, and usually what happens if that's the scenario, whatever the bottleneck is, its utilization goes through the roof. And so you can try to pinpoint things that way. But what SQLIO will not show is if there is a problem with one of the underlying components. You're going to have to test every one of those guys, and I'd highly recommend doing that using the vendor or manufacturer specified tools to test each one of these components. This may not reflect your architecture, so you need to be able to test all components of your storage architecture to make sure that you're getting consistent throughput through all of that. Like for instance, if you test your LUNs, your storage controllers, they all seem to be able to deliver 2 gigs, your fiber 2 gigs, and then your HBAs for some reason are only delivering 1, then you know you got a problem with your HBAs. So I just want to make that clear. And I want to now move on to these results. So this is and hopefully you have a better appreciation now for what these results mean. So again, I did these results using a 64K block size. I did use random reads and writes, even though they're not really appropriate for data warehouse workloads, just to compare and contrast them. So here's my my sequential reads, my query performance, and they max out at about 1500 megabytes. You see how it levels off there at 32 operations per second. So I know testing anything over about 32 operations won't do any good. So I picked 32. If I were to continue testing, I would pick 32 for that. and then start increasing my block sizes and see how performance either increases or starts leveling off. And then for my writes, which is the performance of basically my ETL, my inserting data into my data warehouse server, that's about at 1200 megabytes, and that actually maxes out way before that, so at about like 6 or so, 8. Yeah, we'll just call it 8. At 8, it maxes out there. So now, with those two pieces of information, you're armed with the throughput capabilities, hardware capabilities, through the extended events and query I/O statistics. You know the query profiles of your queries, and you can start making very, very good estimations as to, okay, if you want to increase your query response time, how much throughput is required there, or even if you add data to your data warehouse, and your query profiles change, how greatly will that affect your limited throughput capabilities. So hopefully that gives you an understanding of that. Next, I want to just come back to this. I know I introduced it in the first slide. I just want to redress it now that you understand a little bit more about SQLIO and different architectures. So the green line, the highest performing line here, is a fast track appliance. This one's made by Dell. This is what's called their Quick Start Data Warehouse, and it gets 2 gigabytes per second throughput. And 2 gigabytes per second throughput, in all honesty, is kind of the starting point for data warehouse type workloads. Really, I mean, if a server isn't getting 2 gigabytes per second, then it's not really correctly architected for data warehouse type workloads. The next one here, the blue line, this is a direct attach with solid state drives. Now you'd think this would be really fast, but these were in RAID 5 and not correctly architected in terms of parallelism for data warehouse type workloads, even though this direct attach is probably on the order of 3 to 4 times more expensive than the Quick Start. The Quick Start is just regular hard drives, spinning disk, no solid states involved whatsoever, but because they're parallelized and correctly architected, they get much better performance for data warehouse type workloads. The SAN, the purple one, the first SAN, this is like a tier 1 SAN, very expensive SAN, and as you can see, it only gets slightly above 1,000 megabytes or a gigabyte a second throughput, even though this is probably on the order of 5 to 6 times more expensive than the Quick Start. The little light blue line here, this is a SAN that is just supported by hard disk drives, so this would be like a tier 2 SAN type situation, about twice as much as your Quick Start in terms of price, and of course your performance is just, well, these solutions are not architected for data warehouse type workloads, for sequential reads writes, for maximizing throughput. And then, of course, my red line here is my own personal laptop's throughput performance. So there you go. Hopefully that gives you an idea. As you download and you run SQLIO on your own systems, you can gauge where you fit within the spectrum. And as you see, having the correct architecture, even though you don't have the most expensive hardware, can really deliver dramatic performance increases. So. And that will end that section. In the next section, I'm going to really dive into that, particularly that Quick Start Data Warehouse, the fast track reference architecture, and actually show you what that looks like. So I hope this has been very informative. That chart that I showed you just recently, this represents about a year's worth of effort, and it really is can be a very powerful chart in seeing how your particular hardware matches up to best practice hardware and things like that, and trying to maximize the performance for your hardware investment. Thank you for your time.